Okay, well, direct. Let's start now with the chi-square.
Yeah, that's true.
The chi-square techniques that we have. I remember the last time I asked you to go and maybe have a look at what chi-square is, what does it do, when do you apply, which kind of chi-square. So did you try to do that?
I can say
Mm.
I did check on it, but mostly it's the independent T type of chi-square that I was somehow I read more about it. You see, the independent.
The independent T chi-square.
Yeah, is it called the independent?
Which is
I think it's
what is called by the independent T chi-square.
It's a type. It's a type of a chi-square, is it?
I've never heard about that. Independent T chi-square.
Independent T.
Which one?
This one. This is under. It's under chi-square, is it?
It's not a chi-square. This is comparing means. The first place you don't deal with chi-square when comparing means.
When you're comparing. Independent t-test.
If you hear anything to do with the t-test and the chi-square, those are two different things.
They are two different things.
Yeah, t-test we use when you are dealing with the means. Chi-square. Chi-square is when you are dealing
because under chi-square, yeah, see even under chi-square, there are two types. The independent
t-test.
Why are you confusing me, Blasio?
No, confusing me. I'm just wondering. I've never had.
Are you sure? 287, yeah, it's here.
In fact, that's an unparametric kind of chi-square. When the data is small. But let's go there and check.
So chi-square
287.
Chi-square it's on both.
Yeah. You're shocking me, but I need to also read about that. Didn't you know there's something of the sort?
Let me see.
286. Good.
Independent sample.
Maybe you said chi-square for independence. Not independent t-test.
Yeah.
I was wondering, I was wondering what are you talking about?
There are two types of chi-squares, both involving categories.
Chi-square, for goodness of it.
That one is referred as one sample chi-square, and then for independence, chi-square for
test for independence. Yeah.
That one is the one that was confusing. I'm sorry.
Yeah. Now you're talking like 10 men now.
Yeah.
Okay. So let's just look at those. No, just go back up there so that I know the very specific term to use when now. You know, in most cases, I know how to apply all these things, but maybe the terms. Yeah, sometimes. So let's go like the first one, the chi-square goodness of it. Explores the proportion of cases that fall into the various category of a single variable and compares this with the hypothesized value presented here but can be obtained in a parametric test. Good. I remember I showed you that. Now I know the very specific name. Chi-square goodness of it. It's like, did you understand what they meant?
Maybe explain.
It's like you have gender, right? So you want to see between men and female who have the highest proportion representation. Maybe the percentage of male is 52, percentage of female is 48. So you want to test if they are significantly different from each other.
Oh, yeah, I've remembered.
Right?
Yeah.
Then I think for independence, now it's now the association. It is measuring the association between the two.
Yeah.
Does this actually have an association with the other. Does it is it I don't think it's not totally causal effect, but just testing, do they have a significant relationship with each other? I don't know if you are getting me. Like, does gender and performance in high school have a relationship so that girls can perform better than boys?
That's what so,
but now it's specifically for two categorical variables. It compares frequency of cases found in various categories, and I'm sure this is found under parametric. Now let's go. I now know where to apply this. Now we want to use several categories. As in, we want to use how do you call it?
For good fitting.
In the various category of a single variable compare. Let's get good data. Good data. This one I had a lot of categorical data. Now we have like marriage. So either you are married, single, or separated. We have like gender. Either you are a male or a female. These are nominal. Then we have age, which is ordinal now. So for these, we are going to use the 3 for demonstration. Okay. We are going to use gender, which is nominal and has only 2. Marriage, which is nominal, it has 3. Then age is ordinal. Because chi-square, we are dealing with the categorical variables. That's what you need to know. Okay? Yeah. So let's start with the chi-square test for goodness of fit. Yeah. We just want to see between male and female who have had the highest proportion. Let's run the descriptive. Let's run the descriptive for gender. So male is 204, female is 50. Male is 80%, female is 20%. But we want to see, are these two proportions really significantly different for us to conclude that they are more male than female, right? Because these are just raw percentages based on the sample, but now we want to infer to the population. So for us to test the goodness, the chi-square goodness of fit, which now tests the difference between the two categories, we don't have that for parametric. So in SPSS, we shall just use this for non-parametric. Okay? So this is the procedure. You come to analyze, then non-parametric, then after that, legacy dialogue, then chi-square. Right? So when you run the chi-square, we take the genital, we put it there. You can use the exact, it doesn't have a problem. Now, here, it's you to choose. All categories are equal. Or you may decide to choose a value. Let's start with the 2 being equal. We want to see, are they really significantly different from each other, the 8 and 20%. Then when you click OK, this is now the chi-square. Okay? So you realize that according to this p-value, it is 0.00, which is less than. So what do we do? What do we conclude? It is significant. It is significant. So
they are not they are significantly different from each other.
So are you accepting or rejecting the null hypothesis?
We reject the null hypothesis.
Reject the null hypothesis. So these are significantly different from each other. Now what else did I want to check? Now let's assume we have the two, 80% and 60%. We want to see, are they really significantly different from 50%? Both of them. Now we use the same procedure, but now we set a value. You look at this part. We set a value. So 50% is the same as 0.5. That is not reacting. Not reacting at all. It's just okay. I don't know why it's reacting like this, but it's supposed to reflect. No, it's not supposed to. 0. Even is 0.6. It's taking me back here. I don't know why it's not.
I'll confirm from YouTube.
Yeah, maybe I'll confirm.
It's 19 hours.
I think the data bundles are not. And what we do, you just also try to confirm about that. At least you know the procedure.
Yeah. And
I'll also try to confirm when we meet, even if it's tomorrow. It's good. We start with this as a refresher. Yeah. You know why? But this is how you are supposed to say it, and then you check the difference between the categories. And let me try to use a different one.
I have a question.
Yes.
When we did run gender in descriptives,
yeah,
you have clearly seen that it is different. They are different from each other. It's clearly seen. It is easily noticed there. Is it? But still, we go ahead and test if they are significantly different from each other. Can you try to explain the difference? Because
the difference is very simple, and that's why I was in the first place asking you that aspect of accepting, rejecting. You are dealing with a sample. You have not collected information on every person.
That's true. Yeah.
Right? So this difference is for that sample, not for the whole population.
The difference that I'm seeing now is for the sample.
For the sample.
That's true, yeah.
But now you want to generalize to the whole population. So there are those techniques. There are those, I think when you want the methods, the very specific derivation of those techniques, you can read them. But they are designed in a way that you are now supposed to infer to the whole population. Right? So that's why we always state for significance. This is just for the sample. But in real sense, it might be not significantly different based on the sample size.
Okay.
I don't know if you are getting.
I'm getting. You are trying to mean from here it can still appear that they are different.
Yeah.
But when you check user, maybe
it will tell you that
they are not different.
They are not different at all.
At all.
Yeah, and it happens.
So from there it means it's referring to the whole population.
Population now. Like you can generalize that they are not different. The proportion of male and female. It's just now let me give like 51 and 49.
Okay.
And you have not a population, a sample of 100. Then you get that women are 49%, male are 51%. Are those really significantly different from each other?
Repeat again the question.
You have a sample of 100. Right?
Then
you have 51% is male, 49% is a female. 51% that is like 101. Let's assume it's 101 or 102. No, 202. Around 202. Then for female now it will be 190. Let's say 80. Yeah, and that is a sample. Male is around 202. Female is around 198. When you look at that and the whole population now, are they really significantly different? Maybe you have just carried out, let's say, like on this plot, we have a mixture of male and female. Then you sample this house alone. You want to see how many males do we have, how many females do we have. Then you come and generalize with the whole plot. With this sample for this house alone, it will tell you that on that plot there is no woman. There's no woman because you have not found a woman in Blasio's. But in recent there are other women on this plot. Yeah. So you see, the sample might not tell exactly what is in the population. So we are trying to infer to the population. So I hope you have got the point. So with that kind of chi-square, which is the goodness of it, we have seen its importance. It's when you are having only one categorical variable. But maybe you have two categorical variables. You want to see what is the association between the two. Yeah. So you come to this descriptive. You can use the cross tabs. Right. When you come to the cross tab, maybe we want to see if there is an association between gender and marriage. Right. When you come to statistics, let me click on the statistics. So gender and marriage, are they, in fact we click the chi-square first, are they nominal or ordinal? They are nominal, so we choose from here. The ordinal we choose from here, nominal by scale or interval you choose from here. Let us just tell you to what extent, what is the size of the impact. So with the chi-square, I'll be interested in, let's say, like phi and gram. But I'm not 100% sure of all these others. So we shall search. When you do that, then you click OK. You'll find it will first of all bring the descriptive. It shows you the distribution of the sample. But from the distribution of the sample, you now come and see here. Is there a significant association between the two? Right? If it's a 2 by 2, then we have what we call the Fisher's information, but this is not a 2 by 2, so it cannot calculate. So we have the Pearson, the likelihood, the linear by linear. These are several methods for these. But the Pearson, there are several methods for these. So from both the three, I've never gone into details to look at the three methods in terms of formulation of that formula. Because when you look at them, they are bringing like different, but the same. The message is the same. It's only that the values are different. Yeah. So maybe we can also go ahead and we check on the details of the methods. But from here you can realize that there was association based on the three methods, right? Yeah. So there was association by what percentage? And I think the grammars will give you that this metric measure. will give you the percentage. So if I told which was the dependent and which was the independent, maybe marriage depends on the gender. So maybe a person being a male, which one is 2, which one is 1? I think male was 1, this was 2. So it is like a person who is on the married. So a male is likely to be married compared to a female. So a male is likely to be, the chances of a male getting married are like 23.9% better compared to, or 23.9% higher compared to chances of a female person getting married. So I think that's what is meant. We also have the ordinal biordinal. I just want us to check on that. Cross tab. Let's remove the. So you have maybe like gender, then the qualification, right? So when you come to statistics, you are not interested in nominal because these are ordinal.
Okay.
So let's use like summer and the quintile, centile. I think they are best used when the data is small.
But only one is ordinal. Why did you consider ordinal? Yet
qualification.
There is one nominal, the other one is ordinal.
Which one is nominal? Which one is ordinal?
It's nominal. That one is ordinal.
P1 diploma degree. Maybe this issue of others. Of course, when it's others, it means it's above this. So let's assume, okay, let me use a different one, but this is ordinal. Let me use like experience. Experience. So it is age, experience. So so this is the table of just distribution of the descriptive statistics. This is now the chi-square test. All the 3 methods indicate that there is a significant association between the 2, right? So we come to Summers D. We call it Summers D. Right. So from the Summers D, I had gone to this document. The things I've not captured it for quite some time. Hey, that what document? Where have I thrown it? Yeah, it is. So for ordinal biordinal, we have the Summers D. For the Summers D, it's like the way to interpret it. Is the way to interpret it. For the results of symmetric measure statistic, the gamma is equal to 9.8, which was significant. Right? For our case, what was the gamma? The gamma is this, which is significant. Right? So according to this, if it's significant, it indicates that the strength of the association is strong. So it might be, it is more, when interpreting this, it is the interpretation is like that for correlation. Okay. Yeah. So when it's below 0.5 here, then it's relatively moderate. But maybe if it's 0.1, approaching 0, then it's weak. The relationship is weak. Yeah. But for our case here, most likely the relationship is moderate. Moderate. But it's significant, right? So when it comes now to the the other measure, that's how the this 1% denote. So here we have found that it is moderate, but by how much? When you improve the one side, will improve the other side. Now this is the aspect of the SUMMers D. So it's good you check between the age and experience, which is the dependent. Experience maybe depends on age. So experience is the dependent. So when you're interpreting the results, you'll interpret for this one. In our case, because experience is the dependent variable. So here it's like an improvement in the age will improve experience by 26.4%. So basically that's how to do the descriptive, and not the descriptive but the chi-square.
That's how it works.
Yeah. So you have seen the difference between the two.
Yeah.
And that's how mostly now you deal with it when it's categorical. So maybe the place you go to stress most is this place now, these three.
To know
yeah, all these. How do you interpret them? Yeah, I have not mastered them very well. But this one I know. This one will show you that there is if it's strong or weak. This one will tell you by how much does it improve. So you can relate it to the linear regression. Do you see how we interpret the standardized and unstandardized beta coefficient? Yeah, it's the same thing here. This one is like the standard and standardized. This is the standardized, because the standardized will tell you by how much. This one and these they are important when you're dealing by nominal with the nominal. But you can check on how to very well interpret them. But I think here most likely they might be there. Let me see. This is still there. Still in the ordinal. But you'll check on that, I think. Yeah, so I think at least today we have done something.
About dummy variable. You only convert a variable into dummy variable only when it's in categorical and you want to use it in multiple regression, is it?
Yeah, at that point it's applied, right? You know, dummy variable is more of assigning values. Yeah.
That were already assigned.
So it's like reassigning now. But when reassigning with a dummy variable, it's like one of the categories. You have to make it like a reference category when interpreting the other categories. The inference to the other categories. Yeah, so in most cases when you are doing the linear regression, you can still apply that. You can even create the dummy variables when doing the chi-square.
Okay. Yeah. I just want
so that it's like you're comparing male to female. If at all male is the 0, then it's like you are comparing now the influence of a female on the dependent variable in the presence of the male.
Oh, so you will only convert if you want to use one of the, maybe let me call them in the categorical. If you want to use one of the, what do I call, is it a label, to be like a reference
category. Yeah. You see, when doing the analysis, let me just let's try to work out with one of the variable here. I think the machine has hung. I don't know what the problem. Oh, here's the problem. So now let's assume. Do you have any? Yeah, good. Then you have the categorical. Let's assume like we have the 3. Married, single, separated. You want to see the influence of that on maybe, which one can we take here? Emotional exhaustion. Okay? The effect of marital status on emotional exhaustion. Emotional exhaustion, it's in continuous marital status. For you to make one of these a reference category, then it must be labeled 0. Whichever will be labeled 0, it will be the one. Yeah. Now that one become a dummy variable. I don't know if you're getting.
After converting.
No.
So it's not the whole of it. It's not the whole of that variable. It's only in the categorical.
How many dummy variable shall we create from here?
If we make married to be 0, it will be there.
No. When you're creating a dummy variable, like these are 3 categories. Then one category versus the other 2. So for example, dummy variable for married status, it is supposed to be 1 to be married and all others to be 0. Yeah. So when running the linear regression for this, it's totally different from. So let's create a dummy variable for married, single, and separated. So you come here and record into different variable. So we have a married, right? Change. What the hell is happening?
This one should be different.
Oh. Let me call married. There's a character that is not needed. Married one. So from the previous one was married, right? Then any other. We need to be very, because there might be missing. Like here you capture them. Then all other 0. Are you seeing that? So that's a dummy variable for the married. Then you also create a dummy variable for the same. Number 2 was
Number 2 was
Number 2 was single, number 3 separated. So let's create for single. Oh, I had already made the dummies. I now remember. That's why they are appearing like they exist. I had already made the dummies. So number 2 is our interest here. Becomes 2. Right? So it's only 2 that's there. It's going to become 1. All others 0. Then the third one was separated. So this one was 3. Any other 0. Good. That for 2, did we really? Oh, for the single I did not complete it. That was 2. Right. Then after that, you now see you have the 3. So it's you to decide which one do you want to use as a reference variable. Now, when running the analysis, you will avoid the reference variable from including it in the regression. So let's try like this. We have emotional exhaustion, but let's use just exhaustion, right? Then when you want to run to see, then you have to leave one of the dummies outside, because that one will now be our reference category. Okay, so let's say we leave single from, no, or let's leave married outside, right? Because married is in between separated and single. We can use that. So, and then we run the regression. So here it's like the married people, when you see a negative sign, it means married experience more exhaustion compared to separated. Single is still negative, which means the singles still experience less compared to the married. So when you are married, you have more problems of emotional exhaustion. But that's not, we want to compare the two.
You're saying if it has a negative, it implies it has a more.
No. If this had a positive, then it implies that no, it is less. Separated has a lesser influence of the emotional exhaustion compared to married, which means married people are likely to be experiencing higher emotional exhaustion compared to the same applies to the single, right? The married seems to be experiencing high emotional exhaustion compared to the single. When you want to compare the two based on the single, then you have this one. So it's like the separated are experiencing a very high emotional exhaustion even compared to the single. You getting that?
I'm getting it very well.
So that's how to run the dummies when doing like regression analysis.
I've learned a lot.
So you are good with that, I think I can now close.